All right. Check one, check two. I think we're live, running on a different microphone, but not the end of the world. But yeah, point up today. We're going to do some introductions. We'll go through the online campus, and then we'll dive into some of the materials for week one and end by running some of the Jupyter notebooks in the online lab environments. So it should be a grand old time. I will share my screen and then we're going to start with some intros and get moving here. So, yeah, I'll start. Hello. I am Alexander Booth. I am going to be the head program instructor and head facilitator for the data science course that you are all in through IBM for the next 10 weeks. Very excited to be here. My background, I've been in the data and AI space for over a decade now. I started my career in industrial supplies, but then moved into sports and sports analytics. And now I currently work for Databricks, which is a cloud data and AI platform, as a solutions architect, where I help both digital natives and sport organizations kind of adopt cloud platforms for distributed engineering and agentic AI use cases. Regarding the IBM class here, I've been teaching data science since 2019, online since 2020, 2021, and I've been teaching this IBM data science bootcamp for maybe about 8 months now. So this would be kind of our third go around. So got some experience and should be a fun class. Karen, I'll let you do some intros and then we'll dive into the materials.
Oh, me? Okay.
Of
I'm
course.
I'm Karen. I'm going to be the teaching assistant here. So, and my background, I guess, in data science and so on has mostly been learning for the past, 7 years. I do a lot of stuff with generative AI now, or with building agentic AI projects, which are just independent projects. I'm not really working for any particular company for that. And yeah, I don't know what else to say right now.
Yeah, no, appreciate you. You'll see Karen and myself. We're going to be in the forums a lot over the next 10 weeks. Of course, the bootcamp is asynchronous, so you can be watching this video whenever and wherever you are. And Hinson, again, thanks for joining. I think we had another student on earlier as well who had to drop. But yes, because this is async, we're going to be doing a lot of chat and conversations in the forums. Karen and I log in multiple times every day, so make sure, and we get alerts whenever anyone posts. So please talk as much as you want in there. We'll review kind of the forum layout here in a second. All right, let's get jumping into things. So with week one, our goal for this week is to, again, like I mentioned, introduce the course, introduce the workflow of how a typical week will go, and then talk about the data science methodology. Our goal this week is to start thinking like a data scientist, not necessarily to write any code or do any machine learning or do anything fun quite yet. But that'll come starting in like 2 days when Module 2 launches on Wednesday. So yeah, let me actually start by bringing up my quick description of how the course will go, and then we'll dive into the course, I guess, the actual Get Smarter environment. Boop, 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 boop. Here we go. Cool. So, like I mentioned, we're currently wrapping up week one here. Week zero started last week. That was orientation week. Our weeks run Wednesday through Tuesday. So, technically, week one started on, I'll pull my calendar here on another tab. What day is it today? Today's the 20th. The week one started on April 15th. So your orientation started on April 8th. And we'll be running through, I think, kind of the beginning of June here. So it should be a fun 10 weeks that we'll fly through. In each week, you will have one live session on the Mondays at 1 o'clock Eastern Time. They will be recorded and posted to the forums as well as the Zoom link. And I also back everything up on my YouTube channel. So you can also go and find the recordings there as well. Live attendance is encouraged because we talk about a lot of stuff here, and it's a good way to, I guess, synthesize everything you learned in the week. But yeah, every week you'll have a similar rhythm. You're going to start with what we're going to call media sets. which are going to be just different chapters of the module. These media sets will include readings, they will include videos, and they will include coding and writing and creating code in different ways. Scattered in those media sets will also be discussion forums and discussion prompts, which we'll get into a little bit later. And like I said, this live session comes typically at the end of the week. That's why we're on the Monday when we're on that Wednesday to Tuesday schedule. And it's ideal if you've already worked through most, if not all, of the media sets prior to the live session. Expectations for the live session, I will typically choose all or a important sample of the media sets from the week and review them live. So typically it'll be the more complicated coding notebooks, or as we get into later weeks, you'll see that kind of we build during the week, and maybe the last activity before the live session is going to be more of a keynote project of the week that starts synthesizing everything together. And so I'll be reviewing those notebooks live as well. Any content from the week is always going to be backed up on my GitHub. We'll review what this looks like here in a minute as well. But you can already see for this week, Module 1, I've already run and backed up all of the notebooks that you're expected to be running this week. Again, you're not writing any code. We'll review these notebooks live in a little bit later on in the live session. Um, cool. How else I also do the live session? It's 90 minutes. The last 30 minutes is supposed to be more office hours, but typically I lecture for almost the full 90 minutes. And in the last 15 minutes or so, we review the quiz, which I'm about to get into, as well as open it up for any questions. And again, the more students we have in the live session, the more beneficial the quiz, Q&A, and stuff will be. Cool. So that last thing to notice to end the week, weeks 1 through 9, not only will you have these media sets, you do have a graded quiz at the end of every single week. So for week 1, our graded quiz is down here in 110. You need to complete each quiz before you can move on to the next week, but you do have multiple attempts and it does tell you which questions you got wrong. So hopefully with 5 attempts, you can get whatever quiz grade that you want. Note that some of the questions are worded a little bit funky, and Karen and I are constantly reviewing the quizzes, the wordings, and things just to see where we can improve, how we can make these quiz questions better. So, like I said, I try and review most of them live, but if you have questions about the quiz, feel free to drop your question into the forums and we'll answer and give you whatever answer you're looking for there as well. Long story short, do the quizzes. Weeks 1 through 9, all the quizzes account for, I think, in total 30% of your grade, with the last 70 coming from the capstone project that Karen and I will grade ourselves at the end of the course. Do the quizzes. They're not too bad and they're pretty quick. Note that completing all the media sets and running all the notebooks, none of that is technically required. You could just jump straight to the quiz. And we'll talk about how the weeks will flow here. We'll just do that kind of now, actually. So the weeks will flow kind of in this way, and some of the weeks are heavier than others. For example, Module 4 SQL. This class is designed for anybody to take it with no experience in the space. So because of that, when we introduce new languages like SQL, or even in week 2, when we introduce Python, there's going to be a lot of material, a lot of media sets, a lot of notebooks. So if you already have some familiarity with the language, you can skip through or breeze through some of the more intro descriptions and the intro activities and jump straight to some of the harder ones that directly affect kind of what we're talking about in terms of big ideas. But if you're new to the space, then definitely taking that time to work through every single notebook is highly encouraged. But again, it's just the quizzes that are graded at the end of each week, as well as the capstone. And again, Hinton, if you have any questions as we're kind of talking here, feel free to drop anything into the Zoom chat. Karen is live monitoring that. So definitely feel free to drop some live questions in if you have any. Cool. So let's go through the weeks. Module 1, we're starting out just thinking like a data scientist. How are data science projects structured? What is the CRISP DM methodology? We'll talk about Rollins as well. Kind of what does it mean to do science on data? Weeks 2 and weeks 3, we're going to get started on Python. Python is going to be the main language of choice we'll be using in the boot camp. We'll be using Python for data engineering, so going out to data sources, bringing data into our environment, cleaning it up, preparing it, and getting it ready for analysis. So that's going to be modules 2 and 3, intro to Python. What is Python? What is writing code? And then how do we use Python to get data? And how do we start massaging, cleaning, and engineering that data to get it ready for analysis? We'll be hitting APIs and doing some web scraping. Module 4 is our SQL database week. We'll be reviewing kind of the history of databases, relational databases versus NoSQL versus warehouses and data lakes. And then we'll dive into using the SQL language on Postgres, I think it is, and SQLite, and start connecting databases to our Python workloads. So when we talk about ETL, extract, transform, load data engineering workflows, how do we take data from source and put it into a database? And also vice versa, how do we get data out of a database to then use for data science and analytics? Week 5 is all exploratory data analysis. We're going to be building visualizations, looking at correlations, building some lines of best fit, looking for patterns. Module 6 is all about data visualization, creating dashboards, creating business intelligence workflows, and creating communicative insights using data viz. Then we get into the fun stuff. Week 7 and 8, we're going to be doing a deep dive into machine learning. We'll cover both supervised and unsupervised topics, as well as linear models, tree-based algorithms, and we'll dive into, at least in breadth, on neural networks and some of the modern kind of AI stuff as well. We're mostly going to be focusing on what does it mean to do a machine learning project end to end? How do you evaluate machine learning models and how do you deploy and productionalize machine learning in the scope of a business data science ecosystem? Finally, we're going to roll out the boot camp by doing a real world capstone project. We're going to be taking real data from a real API kind of around SpaceX and space launches. We're going to be then doing all of the weeks that we did before. We're going to go fetch that data. We're going to clean that data. We're then going to write some SQL queries against that data, make some visualizations, and then we're going to end up with a machine learning model that predicts the success probability of a given launch, as well as some interactive dashboards to help us dive deep into what the data behind the model is actually saying. So pretty fun. Note that in weeks 9 and 10, the media sets build on each other, where we do need to complete each media set and actually run the notebooks, write the code, because all of that is going to be geared towards your capstone deliverables. So just to recap, in weeks 1 through 8, the media sets, the videos, the code, technically optional. You just have to do the quiz. But in weeks 9 and 10, you do need to write all that code because that code will be submitted as part of your whole capstone project. So obviously do the work, right? That's kind of what we all signed up here for. Um, cool. Let's see. Hopefully, you've already gone through the orientation modules. There's a lot of content there. The biggest ones is mostly anything to do with Python, so that you're prepared for the gauntlet that is week 2. And yep, we'll be posting YouTube links, we'll be posting GitHub, and hopefully you all kind of know what you've signed up for here. Cool. Um, Sounds good. All right, just let's dive into the actual platform itself now. Let's go into week 1. So the week 1, like I mentioned, you're going to start with these media sets. These media sets are going to contain readings. They're going to contain videos to watch. They're all pretty short, but you're going to kind of click your way through, watch all the videos, do some learning about things. And there's no notebook in this stage, I don't think. But then each media set will end with a practice quiz. These practice quizzes are not graded, but I do recommend looking at them because guess what? These practice quiz questions correlate really, really well with the end of unit quiz. So if you can solve these questions, you can probably solve the end of unit quiz as well. Cool. So that's an example of a media set. Let's get into an example of the discussion forums, and then we'll look at a media set with a coding notebook in it. All right, so periodically scattered throughout the week, you'll run into these class-wide discussions and class-wide forums. First thing to note, the forums are always optional. You do not have to talk to us if you don't want to, but I miss you and I love when people talk. So yeah, Hinson, thanks for contributing so much already. The forums, you'll notice that if it's a discussion forum based on the content, it's going to be prefixed with learner discussion as well as the section of where it's located. Most weeks will have at least one. I think the longest is there's one week that has four learner discussions. So again, the more you participate in the learner discussions, the better it is for the whole class. Either way, though, Karen and I will try and contribute as well, just to get the conversation moving. So yeah, week one, we have two discussion prompts here. So yeah, here's an example of what one looks like. Post a real world data sets, compile some questions. Again, thinking, being curious about the data that you would like to explore in terms of patterns with the data set and engage with your peers as relevant. So, yeah, the Titanic data set is very famous. It's a very, I think we'll talk about it in the boot camp as well. It's a good one. But yeah, it's good for data handling, data engineering, working with null values, creating new features, all of that good stuff. And yeah, the questions around gender and age. One of the other interesting ones about the Titanic workflow is also the like financial like demographic, like whether they're in floor one versus floor three, and whether or not they have a cabin or not, as well as looking at family size. If it's a larger family, maybe they're more likely to survive versus if it's just a single man, right? So that's some really interesting questions there. And if you actually want to broaden your horizons beyond just the regular Titanic, Kaggle has another one called Space Titanic, which is pretty fun. It's a little bit more of a difficult problem versus Titanic, but it's got very similar types of problems in terms of the data and the data cleanliness. Yeah, that's kind of again, we're just walking through the example of what a learner discussion forum topic looks like. Besides the learner discussions, you'll see two other types of forum. The first will be the lounge, and the second will be the live session or general questions. So the lounge is exactly what it sounds like. It's a more casual place just to ask questions or just to post updates. I use the lounge to post weekly updates. Um, just so how I post updates, I try and do 3 posts a week. I know, I go crazy being online all the time. But I usually do a week preview. So on the Wednesday or Thursday that a module launches, I'll post my backups of the notebooks as well as just a preview of what to look for. On the live session, obviously, I'm going to post a live session recap with the link to the recording, as well as just a recap of what we covered. And then I guess maybe I only post twice. No, I do three. Two, three. I don't know. Then on Fridays ish, Friday, Saturday, Thursday, Friday, I try to do a recap slash preview. So I'm actually gonna do a weekly. I'm gonna upload to YouTube another video every week. That's just like a quick recap of week one and a quick preview to what's coming in week two. So you'll see 2 videos and 2 to 3 forum posts from me every week. Again, that is going to be the live session recap, and the live session recording, as well as another video that will recap the prior week and preview the next week. And then I'll try and do like a text post as well on the day that a module opens, just so you kind of know what it looks like and you have my notebooks as backups when things break. Cool. So use the lounge, ask whatever, post memes, post news links, or ask some questions, whatever you want to do in the lounge. Typically, the lounge though is more like casual. And then we have the Q&A general discussion as well. Typically, how this is used If you have any questions leading up to the live session, maybe something's not working in the media sets, maybe you have questions about the notebooks, maybe you have questions about the quiz, drop it in the live session Q&A, and hopefully I can answer any of these questions live during our live session. I also see students posting here with just any like technical Q&A, even if it's after the Monday. So even if it's after the live session. If something's not working or if something's broken or you have a question about a quiz or you don't know the code to write for something, then yeah, drop technical questions into the live session Q&A and try and drop just general questions into the lounge, as well as check the lounge for weekly updates from me. And like I said earlier, because this is async and we only have 90 minutes live every week, Karen and I spend a lot of time in the lounge looking for questions, looking to debug, and I usually go pretty over the top in providing the notebooks and stuff. So yeah, just for an example, this is my GitHub link. If you don't have a GitHub yet, I strongly recommend signing up. You will be using GitHub to submit the capstone project, and it was reviewed in the orientation. But we will review GitHub in a little bit more detail in week 9 when we do launch the capstone. But if we check my GitHub, you'll notice that I have, like I said, backed up every single notebook that you're supposed to run in week 1. And I'll also be uploading any notebooks I live code during the live session as well. So if you do run into issues with the notebooks, like something's not working, I run these every day, like every week. So I will take them from the media set, which we'll review in a second. I download it, I run it, and I make sure that everything works. I even like fill in the blanks and stuff as needed too. So if you ever run into issues with the code, use my notebooks as a source of truth. So you'll see kind of this 1.4 notebook. You're going to be grabbing all these recipes and then doing some data engineering and stuff. And again, for week 1, you don't have to know what any of this code does. It's all given to you. We're just going to be reviewing big ideas of the code. Again, we'll get into that in a second. But yeah, long story short, use my notebooks as a source of truth. And we'll also talk about going into next week how we can run these notebooks in other environments if the IBM cloud is giving us issues. Cool. So let's review kind of what a media set with a notebook looks like, and then we'll get into the big ideas of, oh, and then I got one more. I got one more thing on the forums, on the discussion, on the, I guess, the campus, and then we'll dive into the content. All right, so this media set 1.4 should have a notebook. And so we're gonna watch some videos, we'll learn all this stuff, got some links, all this cool things. IBM data science methodology. And here we go. So this is going to be our lab. So you notice this is going to be called an activity and it's going to open a lab. I always recommend opening these in a new tab. So I just right clicked, open a new tab there. And this is going to set up a lab environment. All of our notebooks are run on IBM Cloud. What that means is that you do not need to install Python locally or run any code locally on your laptop. We're always going to be running these labs in a browser. Of course, you have the option to install Python locally, and the orientation materials reviewed how to do that. And if you wanted to, if you right click on a notebook, you can download them to your local machine. So you do have the option to run these locally, but it is definitely not required. And in my opinion, the hassle to set that up may not be worth the effort, right? So, but if you already have Python installed and Anaconda installed, then sure, totally you can download these and run them locally. But like I mentioned, this is primarily going to be run on IBM's cloud. What that means is the kernel that we're going to be connecting to, that is just the cloud computer that is going to be powering our notebook. Usually it works fine. This one looks like it's going to go fine. But just like with any cloud service, there may be times of day or periods where, because we're on like I don't know, because this is like IBM's cloud, in my opinion. Sometimes the compute may not be available, or they may not have the bandwidth to give us a compute for our campus or something. Again, like it should work, but sometimes it doesn't. But yeah, we'll walk through how to debug these notebooks and things. Big idea though. When you get to coding activities, your goal is to open up the lab environment on IBM Cloud and then run through the notebook. That's what this is called, a coding Jupyter notebook. Fill in the code and run it when it prompts you and kind of just work your way through it. You do not have to run this locally, but it's recommended to run these in the cloud. Cool. Before we get into the notebooks, let me Module 2 materials should be released this Wednesday. I see the question in chat. We're currently in week 1, and you can definitely start working on week 2, even though you're a little early on week 2. Basically, how it works is like it needs to be unlocked. I'm gonna go into a student view because that's a great question, Hinson. Um, but yeah, we're in week 1. Week 2 officially launches on Wednesday in a couple days. Yeah, let me kind of walk through what that looks like. So that's good because that's the last thing that I wanted to talk about as well. All right, so the last thing I want to talk about on the campus is what things look like kind of as a student. Because I want to talk about how to get to our announcements, our live sessions, the recordings, as well as how each week kind of unlocks. So yeah, it looks like they unlocked both week 1 and week 2 at the same time. So this is what I'm seeing in my student view. So Hinton, that's probably what you're seeing as well, that week 2 was unlocked next Wednesday. But yeah, it's weird that they're unlocking these a week early. I was gonna say, I think there's a bug in that, Karen. Maybe we need to report that back up to CS Sonda, to our leadership. Module 3 shouldn't open until the 29th. Because yeah, we're 100% in week 1 here. And then yeah, it's weird that they gave the capstone. Capstone's already unlocked as well. So that's weird. Capstone should be a little bit later on as well. But yeah, to answer the question, we are in week 1. Week 2 begins on the 22nd. So these dates should be incorrect. But we'll confirm that because yeah, we're in week 1. You're not behind, but week 2 is a doozy. There's a lot of content in week 2 to go over because it does do a lot of Python fundamentals. But this is the week 1 live session from what I know. Do you have any other notes there, Karen?
I still not even understand how you get to be play student.
I go to my profile and I can like change role. I
Oh,
don't know if you have that ability. Yeah.
yeah, that's right.
So yeah, technically, in my opinion, these dates are a week behind or a week ahead. Module 2 begins on April 22nd. Module 3 begins on the 29th, and our live sessions will be on the Monday after that. So great question. Sorry for the confusion there in the course, I guess, description. But we'll also confirm on our end as well. Last thing I wanted to talk about as kind of from the student view, this announcements and resources tab is going to be your best friend. On the announcements and resources tab, you're going to see this announcements thread where I also post. So this announcements, it doesn't matter what you've unlocked or not unlocked if you're kind of running behind on the content. I will always post the Zoom recording links from lecture as well as my recap videos. I will always post those to the announcement forums as well. And low key, I definitely should have posted before this live session to advertise it. So that was my bad for not posting in here on Sunday night to try to get people to remember about showing up to the class today. But yeah, the announcements, you don't have to unlock anything. So I will always be sharing my links and recordings here. So no matter where you are in the boot camp or what's locked or unlocked, you'll always see kind of my stuff. And then you'll also get to the live sessions here too. So if you click on the live session tab, it should give you kind of the Zoom link. So yeah, we're running through my last live session is June 22nd. That'll be the week 10 capstone live session.
Oh, it looks like now I don't have that. I don't have that ability, but it looks like they opened the first module at the same time as an orientation.
Oh, so that's
And
also
then
what
and so
this.
that's all a week ahead because then it says yeah, and then module 2 not available unless it is after 15 April.
Yeah, they should have not released module 1 until orientation week was up. So if they kind of mess that up, then yeah, all the weeks are going to be opening a week early. Yeah, we're officially in week one. Week two launches on Wednesday. I'm the instructor. That's my dictation, and we're running through June 24th. That's 10 weeks, right? All right.
Yeah.
Cool. Last thing to kind of notice here, you should be able to go to cloud recordings and see any recordings. So even if you don't keep track with my announcements, you don't keep track of my forum posts, you can still always go to cloud recordings in kind of the live session tab and see all the recaps and stuff here. Yeah, no, I had a lot of students ask in the past, like, how do I see your announcements? How do I see when the live session is? And also in the live session, it should hopefully automatically update to your time zone. So I'm actually in Central Time, not Eastern, so it automatically updated for me. So that should also help. And then I actually was able to add all of these to my calendar somehow. So I recommend doing that too. Cool. So big ideas of what we just covered. We walked through what the course platform looks like, as well as expectations for each week. Again, just to recap, weeks start Wednesdays and run through Tuesdays. We are currently in week one. In week one, our big idea is to start thinking like a data scientist, which we'll start diving into now for the next 40 minutes or so. Within each week, you're going to have a combination of media sets, which include readings and videos, coding activities, where you will be writing and running code in IBM's cloud platform, as well as discussion forums, where you're recommended to contribute to questions related to the module, just to get you start thinking a little bit more, as well as interacting with me, Karen, and other students in the lounge and Q&A parking lots that we have there. At the end of each week, there will be a live session that'll be recorded where I'm going to walk through most, all, or some of the code notebooks as well as discuss the big ideas. Everything is backed up on GitHub, YouTube, and Zoom, so you can keep track asynchronously at your own pace. And I think that's it. Grades, how do you pass the boot camp? Do the quiz at the end of each week. It's called assessment quiz. There are 9 of them. They count up 30% of your grade. So I think they're worth like 3.5%. I don't know my math. What's 30 divided by 9? Three and a third. So each quiz is worth 3.33% of your overall grade. You get 5 attempts and it tells you what you missed. And I try to also review it during the live session. So get your quizzes done. And then when you get to weeks 9 and 10, the activities that you do all need to be done and saved because we're going to be I guess, submitting all the notebooks you do in weeks 9 and 10 because they're going to be building on each other. You're going to start with getting data, cleaning data, writing it to a database, querying it, building your EDA, building your machine learning models, building your BI dashboards. So it's all going to be cumulative in weeks 9 through 10. Note that in weeks 1 through 8, all the activities and media sets are technically optional as well. You can breeze through or focus on what matters most to you. And yeah, just to kind of reiterate that point, week two, Intro to Python, does a lot. I have a little sneak preview of how many notebooks there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Golly, I'm exhausted. So there's like 20 plus coding notebooks that you can do in week two, right? And again, that's by design. If you have no coding experience, you don't know anything about Python, then definitely start at the beginning and work your way through. But if you have some familiarity, as you start working through the notebooks, you'll be like, I know this. Do I really need to run this? And the answer is no. You do not need to run it, right? Just skim through or just look at my backups, kind of whatever you want, and take it from there. So yeah, week two and week 4 is also like that, the sequel week. There's a lot of like starting from zero or kind of working all the way through. So again, I'll try and call out which notebooks and media sets are most important when we get to the week. Finally, if you lurk on my YouTube or lurk on my YouTube's just a booth in the wild. I'll link it again as well. If you lurk on my YouTube or lurk on my GitHub, you'll see that I've been doing this, like I said, for most of the last year or so. But you can't just copy paste from the past because we do change some of the notebooks boot camp to boot camp. So there, I know that because Karen and I basically report back and we try and get content updated. So that's why I run every notebook the week of. I don't just reuse old videos or reuse old notebooks. We do try to make sure that everything is fresh and working for you all. So feel free to definitely look at past cohorts and past videos just so you get an idea of what we're working on. But your source of truth is always going to be whatever we're doing in our class forum with kind of our course ID and kind of our specific videos. Cool. When in doubt, also check the announcements tabs, check the lounge. That's kind of where we'll always be posting updates. Sweet. Let's dive into module one here. Um, is this my right one? Yep. Oh my gosh, wrong date. What's today? April 20th. All right. Big ideas in data science methodology and thinking like a data scientist. These are just some of the notes that I put together. We'll pull up a couple links here as well. But first, let's kind of define like what is data science? Why do we do data science? Why are we in this boot camp? Why does data science matter when I can just have Claude do all of my work for me every single day? But yeah, data science at the end of the day, it's a structured way of solving problems with data. We want to look for a couple of different things. We want to be able to tell stories with our data. We want to understand the past, understand the patterns, and tell stories about what's happening and what could potentially happen in the future. So, storytelling. And the other big idea is truth telling. Data can lie. We've seen this a lot. You can have bad visualizations. You can tell bad or biased stories with data. So with great power comes great responsibility, right? As we are telling our data stories, we want to make sure that we're telling truthful and trustworthy data stories that, again, if a business owner or user or a domain, they're trying to generate data-driven insights, they need to trust the data and the recommendations that you are providing. So storytelling and truth telling. How do we massage our data to fulfill both of those things? So a couple of notes that I put down here. We want to understand how the domain or how the business currently operates. We want to have a strong background in statistics and analytical reasoning. We have to be able to code. We need to collect, prepare, and model data. And most importantly, automate it. We want to automate data coming in every day, every hour, every minute. We want to automate how that data gets cleaned, processed, and ready for machine learning. And we want to automate how that data gets fed into machine learning models, fed into AI tools, and how those outputs are then kind of relayed back to users. So automation, automation, automation everywhere. But then we're not just done when we build those pipelines. How do we consistently iterate, evaluate, and monitor our models, monitor our dashboards and our data products, take into account feedback from our users, feedback of what the data is telling us as well, and always iterate to make our products better. You're going to hear me declare this idea of a data product a few times in the bootcamp. When I talk about data products, I talk about all the things that a data scientist is responsible for developing. So let's talk about consumption, right? Who is consuming your products? They care about tables, clean tables that they can move into spreadsheets, they can move into dashboards, whatever. So we call this like gold or reporting level tables. That can be a data product. Maybe you are creating a dashboard. You are creating a BI dashboard in Power BI or Tableau or QuickSight or Looker or Click, whichever dashboarding BI tool you want. That can also be a data product, right? It's something used for decision making downstream. Maybe you're making a machine learning model just to supervise random forest regression. That can be a data product. How do we kind of containerize it, deploy it to an API, use it in our data engineering workflows. Maybe it's an AI agent that you're developing to automate or go off and do some deep research for you. Maybe it's a data app, which is actually what we're going to do in week 6. And kind of where does a data app end and a dashboard begin? We'll talk about all of that coming up as well. But it's not just the pipeline of getting data, cleaning data, and exploring data. It's also what is being consumed that you have to think about, right? Whether it's a table, a dashboard, an application, a model, or even an agent. So the idea of a data science methodology is supposed to kind of set your brain thinking about a repeatable framework for creating these data products and using those data products for decision making downstream. So yeah, without a methodology, teams jump to solutions too quickly, models answer the wrong questions, and results are difficult to explain or trust. Again, big idea, storytelling and truth telling. With a data science methodology, we're able to, again, just align our project work in a way that's repeatable. So let's get into a couple that were discussed. Let me see if I can actually find oh, look at that. I already have the documentation up. Boop, boop, boop. Cool. We're going to start with Crisp, even though my notes start with Rollins. Crisp, I think, was the OG. It was kind of one of the original kind of methodologies here, and it's been around for a long time. So this is taken from my kind of my IBM notes here. So the cross-industry standard process for data mining. That's not going to be on the test. I don't think it is. But how do we kind of describe typical phases of a data science project? So note that where's my little pen? I got a little pen here. With any data science project, we're always going to start with the business understanding. To me, this is one of the most important stages. That's supposed to be a star. To me, that's one of the most important stages when designing and working through a data science project. What's the point? Why are we doing this? Right? I like to say that we don't just do data science in a vacuum. Sometimes I do though, as you know, as a hobby or doing something for fun. But typically, when we do data science in a business or an organization, we're doing it for a reason, right? We want to maximize sales, right? We want to lower our variance in how many widgets we're going to sell every single day, right? I want to increase shareholder value. Rah, rah, rah. But there's usually a reason, right? I want to make better decisions around hiring. I want to make better decisions around when I put items on sale or setting dynamic pricing for tickets, right? What is the business problem you're trying to solve? And what is the business culture, their data culture? We like to talk about this. Where's I got my pen up? Um, we like to talk about this on like also in AI, we call this like the AI maturity curve. So again, it's like the similar type of idea. This is coming from Gartner. That's the one that I want. Like what's the culture of data and AI and data? We call this data-driven decision making. How do we get to the right of the data maturity curve? Yeah. So like where are we? Are we doing just cleaning data? Are we making static reports? Are we doing random queries? Or are we actually doing predictive modeling, automated decision making, using AI for some of this stuff as well? So again, to me, as especially now that I work on the tech company side of things, a lot of my customers, I can't just say, oh, they want to make ticket prices better, right? They want dynamic ticket pricing. It's like, wait, my customer is not very mature in their data and technology, right? They're still using Excel. They're doing a lot of manual work. There's not a lot of automations. Sometimes they don't even know or trust kind of their data. So kind of understanding the maturity curve for both AI, data, and tech. Yeah, how do we move from hindsight to foresight? I love that. I think I'm going to share this one in the forum after class. That's a pretty good one. How do we get from hindsight to foresight? Instead of just looking back at what were my sales in Q1 last year, how do we look forward? How do we increase or project or model what our sales are going to be in Q1 next year or in Q4 that's coming up? So again, we're bringing that back to our methodology. What is the business problem? What is the business culture? What is the business understanding of what you're trying to do? Then comes the fun one, which is data, right? What is the data that we have to work with? What is the data that we have to go out to do? And how does this data relate to the business problem that I'm trying to solve, right? How do I get historical ticket prices? How do I get fan dynamics? How do we get C360 stuff? Yeah, sorry, we have the FIFA World Cup is going to be starting during our boot camp, so I'm very hyped for that. I have some of the games happening in my local stadium down the way, which is going to be a lot of fun. So I have like ticket prices and soccer, football on the mind. But yeah, how do we kind of what data do I need if I want to do dynamic pricing, right? What's the expected fans, kind of what's their concessions? Are they going to be buying merchandise, all that good stuff. Once we kind of understand the data that we have, slash the data that we need to go get, we move into data preparation. This is going to be our data cleaning, our data engineering. How do we fix our null values? How do we fix our data types? How do we normalize our data? How do we encode our categorical or text-based data? How do we get our data ready, not just for modeling for machine learning, but also ready for dashboards, business intelligence, AI agents? Again, at the end of the day, it's all data products. How do we prepare our data for consumption via a data product? Then we move into the modeling stage, which again to me is not just machine learning or AI, it's all of it. I'm going to be modeling a dashboard. I'm going to be modeling or wireframing a data application, a data app. I'm going to be designing an end-to-end AI agent. I'm going to be modeling a uh, gold relational tables so that a SQL analyst can just jump in and get the insights that they want, right? How do we kind of model things? And you'll notice the arrow goes back and forth there. And this is because our modeling depends on the data. Garbage in, garbage out. If I have bad data, if I've done poor data preparation, I'm going to be creating poor data models, right, and data products off of it. Finally, once we're happy with the model, we move into evaluation. This is where we loop back in with the business understanding and the business problems. Does our data product, does it help with the data, with the business problem that we started with at the beginning? If yes, then great. Let's deploy our data product and call it a day. We'll move the machine learning model into an API. We'll have the AI agents be accessible via Slack or Teams. We'll deploy a dashboard to Tableau. We'll publish a data application to Streamlit or Gradio or something, and call it a day. So this is pretty good. Again, this was mostly designed back in the day, about like 20 years ago, like back in the day, in the 2000s, and maybe a little bit before that. This was mostly when we were pulling from on-prem data warehouses, your Oracles, your SQL servers of the world. A lot of our understanding and preparation was writing complex stored procedures in SQL and then transforming data in Excel or some other type of software. I remember using Minitab back in the day, which I think is still a thing. SAS is still a thing, I think. SAS software. Let me if I can. A lot of these like old. Oh my God, what's this? Is it SASS? Or those SASS? I think AI overview is being dumb. Oh my God.
Yeah, SaaS is software as a
No, I was
service.
looking for the statistics.
Yeah.
Statistics software. Or maybe SPSS.
SP,
No, that's
SP,
like the IBM one. That was another one. It was like oh, it's just SAS, I guess. Yeah, I was using this back in the day as well. So like using like again, our statistics and kind of analytics was done in a kind of in an old-fashioned way. And again, this kind of led to when we created a data product, it was mostly one-off. What I mean by that is that what we created was a white paper, a research paper, or some kind of dashboard, or I guess not really dashboards weren't even a thing. It was just like static reports, like a PDF that would get put on your boss's desk. So when that's your data product, right? The deployment of that's really easy. It's one and done. We kind of do this work, we kind of generate this report, and we print it out and call it a day, right? But with the advent of big data and with the advent of more advanced machine learning and statistical capabilities, as well as, of course, AI, that led to the Rollins methodology, which was actually made. This guy John Rollins, he actually works for IBM. I think he still does, which is pretty interesting to me, at least. I swear I had a. I think maybe it's this one. No. Maybe this is one of them that we have. I swear that was I had a good PDF. Let me find it. Maybe it was this one. Oh yeah, it is this one. Yeah. And again, look at this. It's a white paper. So it's a single report that was generated and printed off as a PDF and call it a day. But yeah, here's the Rollins methodology, which has a bunch of extra steps, which I really like actually. And if you go into like the media sets and actually watch some of the videos, you'll hear why we have some of these additional steps here. So this is the Rollins approach. Mostly the difference is that we need to break out data preparation into more specific requirements of what we need to do as we evolve data, right? And then finally, the second bit that's different is our continuous improvement of data products. So that's going to be the evaluation, deployment, and feedback loops at the end there. So we'll start with some of the changes that you'll see on the right. Some of the difference is not only do we just go straight from business understanding to data understanding, we also need to start thinking about how we're going to do analytics. What's the end goal here? What am I trying to create? What is going to be my approach to creating these products to solve this business problem? Next, the data requirements. What do I need from my data? What data do I need? What does it need to look like? What does it have to be trusted for, right? What do I need to make this a reality, right? Once we understand the requirements of the data in terms, again, kind of as what I was talking about with the dynamic of pricing. I want to know fan 360. I want to know historical ticket prices. I want to know butts and seats, how many people actually showed up to the game. I want to know concessions. I want to know merchandise. I want to know all these patterns. I want to know demographics. I want to know how much you make given what zip code you live in, right? How do I start requiring or articulating what I want from my data? Then we move into the normal data engineering work. Go out and get your data, make sure that it's valid, it's coming from trustworthy sources. Make sure you understand what your data is actually telling you. And does your data understanding match your data requirements? If I'm asking for concessions data by demographic or by kind of fan pattern, and I get given, I don't know, this is how many times Karen orders Uber Eats, and like that's not really relevant, right, to my data requirements. Even if it does help me understand them as a fan, it's not really what I need to help generate kind of dynamic ticket prices, right? So understand what you're being given from your data and how it maps back to the requirements. And then you may have to go out and collect new data. So then again, as you'll probably see, most of data science is not the fun stuff. The fun stuff to me is like creating the data products, designing your dashboards, putting together your data app, training machine learning models, sketching out your AI agentic system. But if the data is not there, if you do not have a trusted foundation in what this data product is being built off of, then you're not going to generate some useful product at all. It's not going to be utilized, it's not going to be trusted, it's not going to generate value for anybody. So garbage in, garbage out. Keep that in mind as well throughout this whole boot camp. We got to make sure we have good data coming in to get good data products going out. But once we have good data that we like, then we do our modeling, we create the data product, we evaluate it, we deploy it, and then we consistently monitor it for feedback, right? Both from users, but also from just the underlying data itself. So I'll give a couple quick examples of what this looks like. Where's my, or in terms of like the feedback and stuff. How do I trash all my drawings? There we go. They're gone forever. So a couple examples of kind of what this looks like. Let's talk about regular machine learning. I train a model to predict how much ticket prices are going to cost at a FIFA World Cup game, right? Great. But let's say that I train this model on prices and tickets from, I don't know, the 2014, 2010, and 2006 and 2002 like World Cups. That those ticket prices are not going to be reflective of ticket prices in 2026, right? Maybe that's because of inflation, maybe it's because of the popularity of the sport, maybe that's because of the location of the sport. So when we talk about problems like that, we talk about something called data drift. The underlying data that I'm using to build my data product has drifted from the actual reality of now. And that's a really tough problem to solve in modeling and data science, right? How do we make sure that we keep our data accurate so our models and products are identifying the most current and relevant patterns? So this is something, especially if we have a machine learning model as a product that we've deployed, how do we consistently evaluate it and get feedback on it on ideas like data drift? Also now AI agents, because why not? We've got to drop AI as much as we can. If I build an AI agent, typically we want to know how well it performs. So you actually get some like a common feedback loop in AI agents, which is really interesting. So this is why whenever you use ChatGPT, it's going to ask you, was this good? Like give me a thumbs up or give me a thumbs down. But a lot of us ignore that. I know I work in the space and I'm really bad at giving thumbs up and thumbs down feedback to my AI chat systems. So what are these AI companies doing instead? Instead, what they're doing is something called tracing. So with tracing, ooh, yeah, now we're getting some. Again, you don't have to know any of this. This is definitely bonus knowledge, but this is also why you should show up to the live session or watch the lecture because I go off the rails sometimes and start talking about random things. But yeah, with tracing, basically what we can do is we can track everything that you said to the agent as well as everything that the agent said back. So here we go. If I look at this like image, you'll see that. Let me see if I can zoom in. The question that maybe Karen asked, what is the price of Amazon? And then we can see the response of everything that the agent was doing to kind of track that how it thought about it and what it brought back. So what some customers are, what some like Anthropic, they created Claude. What they do is every time you like swear at Claude and you're like, you're so useless, you're so effing dumb, why are you doing? And you're being a bully to the AI, it like logs that and it knows that, oh, Hinson's having a bad time with my model. What is he trying to get it to answer? What are they trying to get it to answer? Why is the model like not succeeding with that? And so without using the thumbs up or thumbs down, we're still able to acquire feedback on how it's being used, right? And so I actually see this even going into like BI dashboards. You publish a BI dashboard and you want to know if a user is actually able to use it correctly and see things and get insights out of it. So after I publish a dashboard, you can track things like how many clicks is it getting? How many views is it getting? And if the views suddenly like take a nosedive, it's like, all right, what are we doing? Why am I maintaining this dashboard? Why am I maintaining these data pipelines if nobody's using the dashboard? Or is it something wrong with the dashboard? Is it something wrong with the business problem? We need to continuously getting that feedback to understand and know in our data ecosystem what's relevant and what's not. So again, just to recap, we started thinking about data methodologies here. We started with CRISP, which is kind of the original, started talking about how we define business understanding, get our data, clean our data, create our product, and call it a day. We talked about the limitations that CRISP has in the modern big data world and big data lifecycle. Specifically, it's more complex to go get data. We need to understand our data requirements. We need to understand our data collecting strategies. We need to understand exactly how to clean and prepare the data. It's just a lot more in this big data landscape that we currently exist in. And then finally, the other big difference, our data products no longer kind of live as a vacuum or live in a short-term life. We typically need to maintain models, maintain data, maintain dashboards, maintain agents forever or for multiple months or years. And because of that, we need to have a stronger understanding of its performance, both in terms of things like data drift, and model evaluation, but also from user experience, right? How are users utilizing these products? What feedback are they giving? And how can we constantly be evolving our data products, right, to meet their needs? So let's see what this looks like in practice, and then we'll jump into the quiz questions and wrap it up. Cool. Also, this AI maturity curve, you can think of it as like any data science maturity curve. They just slap AI in front of everything. But this whole thing of like going from hindsight to foresight, from just looking at data and reports to actually looking at predictive modeling and data-driven decision making, this is a big culture that you're going to need to see at different organizations, and people as well. I'm gonna make sure I covered all my notes. Boop, boop, boop. Yep. Key takeaways, I would start with, yeah, storytelling and truth telling are the only things you need to know. How do we, and being iterative, right? It's no longer a one-time workflow. Cool. The goal is not to just build a model or build a dashboard because you want to. The goal is to make better decisions. How do we increase decision making? All right, let's tackle a few of these notebooks. I think I'm going to try and run all of them. So I think this may not be the first one. So let's start with the first one. For this thought exercise that we're going to do, I guess, with code, we're going to be looking at recipes. So again, with the labs for this week, you didn't actually have to write any code. Um, it's just going to be like how to get familiar with the environment, get familiar with the notebooks, etc. So what you may have actually just noticed there, this little circle, it had a lightning bolt in it for like a split second. That lightning bolt means that it's connecting to compute. It's connecting to a cloud computer. So when it's not working, you're going to see a lightning bolt there for a long time. Like if there's a lightning bolt there, your code will not run. So don't even try to run it. And again, to kind of reset it, you can click on the kernel. You can kind of see that we're running this kernel here. I guess, hold on, I guess it's kernel. Yeah. If you go to kernel, you can go to interrupt or restart or shut down. So just to show that lightning bolt again, I hope this works. I'm going to click on restart kernel. And there you go. So it's reconnecting. And come on, please don't break. Uh-oh. I believe. I was like, I was looking at
Oh
Karen
no,
like, oh my
it's
God.
been doing exactly that.
I'm hoping it comes back. Uh-oh. I may have busted
So
it.
that
So anyway, if I have a lightning bolt here, my code's not gonna run. Oh my God, amazing. It connected. Whew. Whew. Don't worry. We have backups that I'll show the backup for week two, but I may talk about it in forums. Basically, long story short, I recommend if anything goes wrong with the IBM cloud, you can download the notebook. And then you can go to Google Colab, which is colab.research.google.com. And from Colab, you can either connect to my notebooks on GitHub if you really want to, or you can just upload the notebook, that you just downloaded from the IBM cloud, and you can run it on Google's cloud. Google's Google Colab, Google Cloud over here, this is always free. So it gives you some like pretty bad compute, but it works. And for everything that we do in this course, it's more than enough. So if anything ever goes wrong with the IBM cloud or the IBM notebook environment, your backup plan, download the notebook and upload it into Google Cloud, connect the Google Cloud compute, and hopefully that clicks over, and then you can just run everything. Hopefully that, there we go. And then you can just run everything here. Cool. Again, some of the stuff you may have to like fetch. Yeah, Pyodide's a dumb library anyway. But yeah, anyway, cool. Leave. All right, let's get back to our notebook. So our kernel connected, so our notebook is live. And so we're going to start framing kind of a business problem and start getting data and cleaning it up. So our goal is we want to know, given a set of ingredients, can I predict the probability of it belonging to a specific cuisine or specific ethnicity for a cuisine. So if it uses a lot of, well, I'll give it away. If you use a lot of like butter, then it's going to be American. If it uses a lot of pasta and tomatoes, it's going to be Italian, right? So how can we use ingredients to try and predict the probability of a type of cuisine that we're going to be making? So that's kind of the goal here. Notice that we're going to start by acquiring a data set, which was already scraped for us from various websites. Again, great, less work for us, but we will talk about how to do this web scraping in weeks 2 and weeks 3. And again, notice that as I'm running the cell, it has a little star next to it, and my bubble got filled in, which means that it was actively running on that compute. So this worked. We downloaded this recipes.csv file, and I can actually double click it, and we can look at what it looks like. So here's what it looks like. We have our cuisine slash ethnicity here in the country column. And as if I move all the way over, you'll see, does this cuisine recipe contain this ingredient? And so this Vietnamese recipe contains basil, but it doesn't contain almond. I think the only thing it's missing is like a recipe ID. I guess that's the row number. So recipe 1 is a Vietnamese recipe, and it had all the ingredients. It has a yes next to it. So we're gonna find another one. Oh, there we go. There's one. It has cucumber. There it is. Cool. All right, so that's what our data looks like. So our goal now is to kind of work through the data science methodology and uh, take this data and do some work with it. So great, we just wrote back out to that CSV. We can look at our data again. The code, the syntax, that's not what this unit's about. So just know that all we're doing here is exploring the shape of our data. We got 57,000 rows. We know what it looks like. It looks good to me. I'm going to save that, and then we'll just leave it up for now. So here's what we've first done here. We have fetched a data set, and we've made sure that we understood what it looks like. We've looked at its structure, we've looked at its columns, and I do think that we can use this data set to answer our business question. So let's move into the next notebook. This next notebook is telling us we're going to move from data understanding to data preparation. I've confirmed that my notebook is active. My kernel has clicked over, so we should be able to run this notebook. Again, our job here is, given that we have, so I'm trying to clear output of all cells. Because we have now fetched our data, we are now going to be doing some data cleaning. We're going to start getting our data ready for analysis. So these first few cells in my notebook, all they're going to be doing is re-downloading and re-importing the data set. And so we see again down here that our data set contains almost 60,000 ingredients. And now we can get into some fun stuff, which is I want to see if we can identify like a sushi recipe, right? So I want to look for all ingredients in my data frame that contain rice, wasabi, and soy. Again, syntax does not matter here. We're just caring about like, are there recipes that exist with some of this stuff? And yeah, we found multiple recipes. One has brown rice, one has wasabi, and one has soy sauce. One thing that's pretty interesting, if you look at this, we're also matching ingredients that we probably didn't need to match. For example, we matched licorice because it contains the word rice. But do we expect there to be licorice in sushi? No. So again, like as you're writing code and doing this, always think critically of kind of what's coming back. Luckily, in this example, we're just doing some basic exploration, but this is always a red flag. Like, huh, wait, I shouldn't be bringing back licorice, right? So always kind of go slow, make sure you know what you're doing. And I actually do this. I use a lot of AI to code now because I'm lazy, not really, but it's accelerating the developer experience. Also, I got in my tech job, we got told to like hit a certain number of tokens, which is crazy. But anyway, side note, I'm always like kind of a skeptic. And I always make my AI like print things out and tell me what's going on so I can like track as it's doing the development, like whether or not we are making mistakes. And that's actually a good practice for AI powered development as well, as again, this idea of iteration and to go step by step. That's why you'll also hear for your AI tools, tell it to make a plan because when it makes a plan, uh, AI development software development tools, make a plan, strategy. I don't know. This is kind of dumb, but basically, you want to tell your AI to like make a plan before it writes any code. So that allows you also to understand like how it's doing things step by step. Big idea, be iterative, always be critical, and always be checking your work as you go. It's always easier to fix a problem at the beginning of the life cycle of the product life cycle. It's always easier to catch a bug in the data collection or data understanding phase versus a user gives you feedback that your data product is completely wrong and it ends up being a data issue that you should have found in the creation of the product, right? So you want to move left in catching your bugs and issues. Anyway, that was a mini rant. So let's look at some more kind of exploratory analysis here. Basically, what we're looking at is the cuisine, the recipes per cuisine. So we have 40,000 American recipes. So again, that's also kind of a red flag. We only have 57,000 rows. So over two-thirds of my recipes are just one cuisine. So that's not great. We probably want to fix some of that. And I also see that we have some kind of weird typos, not typos, but like Italian and Italy should probably all just be one cuisine. That shouldn't be broken up like that. So we have some bias. We have a bias for American recipes, and we have some cuisine typos that we need to bucket better together. And some cuisines only have a very few recipes. And again, we'll talk about an idea during the boot camp of something called sample size, which basically means the more data you have, the more trustworthy you are of the patterns that we find. If I only contain four recipes, it doesn't really matter what ingredients they have. Like, it's not going to be enough signal or enough confidence that that pattern is real, right? So we also call this signal versus noise. And we'll see that if I only have low samples or low samples for some groups, that usually creates a lot of noise. Anyway, let's do some data cleaning here, from understanding to preparation. So for our data cleaning, we're going to lowercase all of our cuisines. We're going to start fixing some buckets so that Italy and Italian issue, we're going to fix that. We're also going to fix that for a few other countries here as well. And then you may be asking, how do I know I need to do this? Well, you should have looked at your cuisines a little bit more than what we did. But now what we're going to do is we're only going to keep cuisines that have at least 50 recipes. So we have at least a sample size that's a little more trustworthy. And so we're going to see that we're down to 57,394 rows. We're going to end up dropping about 300 recipes. Next, we're going to change some data types. We're going to go from a text string, to an integer. Again, numbers are a lot easier for models to find patterns in. So let's get a bunch of ones and zeros in here instead of yeses and nos. And now let's see if we can find a sushi recipe. I am looking for a recipe that contains yes to rice, yes to soy sauce, yes to wasabi, and yes to seaweed. And when I run this, you'll see, wow, we have a bunch of recipes here. And some of them are Japanese, some are Asian, and some are East Asian. So the question is to start thinking, can we classify all these recipes as Japanese? And the answer is no, because we have some other cuisines here. All right, we're gonna do a little bit more data cleaning. Basically, what I want to do is I want to average out how many times different ingredients show up in different recipes. And we can see here that egg shows up 21,000 times, wheat 20,000, and butter 20,000. And we have durian as an ingredient, but no recipes. So that must have been one of the ones we dropped. Only one recipe with strawberry jam. Oh my gosh. Anyway, the most popular ingredients are going to be egg, wheat, and butter, each appearing in about a third of our recipes. Yeah, like we mentioned, we have a bias for American recipes, but if we group by our cuisine and take the average, we'll actually get a better representation of the proportion of recipes that these ingredients are in. So I guess we'll start with this first one here. Um, Almonds appear 15% of the time in African recipes. And so that's pretty interesting. Notice that American is second. And if I go across to butter, where is it? There it is. 41% of American recipes contain butter, according to this data set. So there you go. And we can start using this to start building a profile, right, of how often different ingredients show up. Again, this is still data preparation. We still haven't actually built a model yet. But just with a quick helper function, I'm able to say that the most popular ingredients in different cuisines are as follows. In African cuisine, 53% of recipes contain onions, 52% contain olive oil, etc., etc. Contrast that to Asian, 49% of recipes contain soy sauce, 48% ginger, 47% garlic. And as I'm looking at this, I'm doing a sanity check. Like, does this make sense to my mind? And honestly, yeah, it does. So English, you got 67% of those recipes contain butter, 41 of them percent cream. Looking at Italian, I kind of spoiled this earlier. Olive oil, garlic, tomatoes, and onion. Tomatoes kind of the big one there. Um, Mexican cayenne pepper showing up 73% of recipes. That's pretty wild. So, Vietnamese fish showing up 73% of the time. Cool. Indian, you got cumin and turmeric popping up a lot. So yeah, this makes sense to me. This passes the sanity check, as I like to say. And finally, let's do the last notebook, which will be kind of the last step here. How do we go from data preparation to modeling? So in this example, we're actually going to build a model that should predict cuisine given the specific ingredients. So I'm just going to click run all for the sake of time here. And as this runs, we'll kind of scroll through what's going on. So note that we're kind of iterating on this notebook. So the first few cells, hopefully my kernel's running. I thought it was a clear white thing. Hopefully this connects over. Uh-oh. Did we bust it in the last notebook? I think this happened in the last class too. Kernel status unknown. That's not what we want.
Bye bye.
That's what I mean when, yeah, so we're not running anything, but my kernel's not connecting. So if that happens, again, like give it some time. Usually a restart or give it a few minutes to connect is a good way. I'm just gonna scroll through this notebook. It's not worth opening it up in Colab, mostly just because, well, I guess I can. Download the notebook, go to Colab, and then upload it in. Cool. So all I did there was it's actually, I'm glad this happened live, I guess. You could see my backup plan. When you're having trouble with the kernel or things aren't connecting, even if you're refreshing and restarting the kernel, um, yeah, Google Colab, connect, and then we should just be able to run everything here as well. To fix this issue, basically this whole Pyodide download thing doesn't work in Colab. So instead, we just need to read that path. All right, and then let's run all these, and hopefully this works. But yeah, you don't need to run this last notebook. But while that runs, we'll just scroll through kind of the example of what we have in our IBM one over here. So again, the first few cells are all the same. We're going to go get the data sets. That's our data collection. We're going to clean up our data set. That's our data preparation. We're fixing our cuisine buckets. We're fixing our data types. And then we're going to start making some visualizations. So the first one we want to do is let's see if we can build a model to predict whether or not a recipe is going to be Korean, Japanese, Chinese, Thai, or Indian. This is a multi-class classification model. And you don't need to know that. We're going to cover that in weeks 8 and 9. But again, for the scope of this example, we want to talk about this through the methodology. So now we're on the modeling phase. My data product is going to be a machine learning model. Let's try out a bunch of different machine learning algorithms. Here's an example of what my decision tree looks like. Basically, if uh, the cumin shows up less than 50% of the time, then we're going to go down to the left here. If roasted sesame seed shows up less than 50% of the time, we're going to go down here. And if starch shows up, oh, it's the other way, right? It's less than,
And
that's
it's not, and
true.
it's not percentages. It's just that it's 0 or 1. So what the tree says, well, if it's
Yeah,
less
yeah.
than 5, then it's 0.
Yeah, we'll get into the decision tree breakdown in
It
weeks eight
doesn't
and
do
nine
it doesn't
or
do
7 and 8.
percentages or anything like that. It
Yeah,
just
I was going fast here because I'm trying to wrap up. But yeah, so anyway, we can follow our tree based on certain ingredients, whether cumin, fish, soy sauce, yogurt. We can actually break down in our decision tree what the recipe is. So for example, if it contains cumin, it contains fish, and it contains yogurt, then it's probably Indian. But if it contains cumin and fish, but not yogurt, then it's going to be Thai. Is kind of the idea there. Or it has cumin, no fish, but yes to soy sauce, then we're Thai. But no to soy sauce, then we're likely Indian. No cumin, yes to sesame seeds, no to cilantro, we're likely Korean. Yes to cilantro, we're likely Chinese. And again, the decision tree identifies patterns in the data to be able to make this tree, right, based on subsets of the groups. Yeah, cumin and fish, but no yogurt, then Thai. Cool. So once we've trained our models, now we can use our models for evaluation and testing. Basically, what we're going to do here is we're going to look at what's known as a confusion matrix. These are just metrics used to evaluate classification models. Basically, tells us how accurate we are. For Korean, we're actually 80% right. Same thing with Indian. The hardest cuisine to predict for us is Chinese food. There seems to be a lot of Chinese food overlap with Japanese and Korean, which again makes sense. Like I can see my model thinking that a recipe is Japanese or Korean when it's actually Chinese, based on some of the similarity in those ingredients. But Indian food is pretty distinctive, and same with Korean. Cool. So yeah, how many Japanese recipes were correctly classified? About 36.6%. In our case, ours was a little bit higher, but in their image, that's going to be that 36 number. How about how many Korean recipes were misclassified as Japanese? Korean, Japanese, um, should also be about oh, actual labels Korean, predicted to be Japanese, 3.33, etc., etc. So, again, kind of a fun exercise. I'm glad you got to see my kernel issues live. And hopefully, yeah, my Google Colab did work all the way through. So, pretty cool. And you'll see that I'm going to get different numbers here than what you saw in the last one. So, that's also something to be noted to know about these models. A decision tree or a tree-based model, it's based on randomness. So, every time you run it, you're going to get slightly different results unless you try to control for that randomness using a hyperparameter. But yeah, we'll get into details in machine learning modeling in weeks 7 and 8. All right, just to kind of wrap this up, I know we're at time here. Big ideas from kind of the week one, besides getting your feel around the campus, is also understanding thinking like a data scientist. How do we go from business understanding to getting data, preparing our data, and then creating our modeling for different data products, whether it's machine learning, AI systems, dashboarding, data apps, whatever. We then saw that in reality with this workflow where we wanted to build a model to predict cuisine from ingredients. We started out by fetching our data or understanding what we wanted to solve, then getting data from various recipe websites. Next, we cleaned and prepared that data. We fixed our data types. We fixed our bucketing. We did all the basic stuff to get trust in our data. Then we moved into modeling, where we actually built a machine learning model to predict cuisine. We evaluated the performance of that model and decided, I guess, not to deploy it into production and leave that as future work. So the only missing steps here would be that evaluation, deployment, and feedback in our loops. But definitely keep this methodology in the back of your mind as we start moving into more real world use cases over the next few weeks. Again, in module two, we're only going to be focused on uh, learning Python and then applying that into data acquisition from APIs and web scraping. And then we're going to double down on that in week three. So we got 2 weeks. We're basically doing the same thing to try and increase our familiarity with Python, data acquisition, and basic data cleaning and data munging skills. I know it's already 1:30 on my time, but I wanted to quickly kind of just walk through what the week one quiz would look like. And then, Hinton, if you have any questions, definitely feel free to drop them in the Zoom chat, but also totally get if you have to hop off. We'll try and wrap this quick. I hate going more than 5 minutes over. So here's kind of the week one quiz. We can take our first attempt at it. We got 10 questions. I'll actually try and do all of them. Let's see how fast we can do it. Which of the following stage is the first stage of data science methodology, business understanding? What happens during the business understanding stage that makes this important? Um, Data scientists take actions to determine what business problem the company actually needs to solve. Again, that's the most important part. Why are we doing data science or making a product if we don't know what we're actually trying to solve here? During the data collection stage, data scientists apply techniques such as blank and visualization to assess the content and quality. I guess descriptive statistics. We want to know how good our data is. A blank is used for modeling. A modeling set, training set. I don't know. A training set is used for predictive modeling. A false positive is a type 1 error, right?
Is that, yeah,
I think so. We don't have time to check our work. Um,
I think it
what
is.
stage, what stage did you correct invalid values and address outliers in the data preparation stage? The final stage of the data science methodology is an iterative cycle between modeling, evaluation, deployment, and feedback. That sounds right to me. Select the correct sentence that describes data science methodology. Blah, 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 blah. I think it's A. The methodology should not depend on specific technologies or tools. It's a mindset. Data scientists typically use data visualization. Isn't this the weird one, Karen, where I think the answer is clustering,
I
but
think
it
it
should
is.
be data viz? And then
Yeah.
number 10. What's the significance of storytelling? Again, we talked about storytelling and truth telling. Storytelling is used for entertainment. Yeah, right. No, that's wrong. Don't do that one. Storytelling is necessary to convey complex data effectively. All right, so I think these are my answers. I think number nine is wrong just because it's a weird question. It's a bad question. But let's see what we get. Submit all. Oh, we got a 90. There we go. And I think the only one we missed was number nine. I think the answer it wants is clustering, which is kind of a silly answer here. So I'm happy with a 90 though. Good job, me. Pat on the
Yeah, that
back.
is kind of strange. A couple of them are kind of ambiguous.
No, I think number nine, I think this came up in the last boot camp. I think number
Yeah, I
nine,
know
the
one
answer is
did.
clustering. But
No, it
the
was the
rest of
first
these I'm
one. I think
happy
it's maybe
with.
the second one even. It was the second one.
I'm happy with all these. Oh yeah, what predictive
The first
analytics?
fill in the what was the first fill in the blank one
No, I'm
earlier?
happy with all the other questions and answers here.
Okay, this one has like was weird.
Descriptive statistics. I think that's fine. I think that's fine. All right.
Tech, apply techniques such as, and then yeah, then you
Yeah,
pick
just
one.
yes.
Yeah.
Is that really a technique? I don't know. But yeah, it's again, just go slow. You got 5 retries. If you've taken it 3 times and you're still getting it wrong, well, you should know because there's only 4 options. But you can also ask us in the live session Q&A forums about any quiz questions, and we will help you out. And if you're mad about one because you hate the wording of it, then also let us know. Oh yeah, this is the one I missed. Mark 0 out of 1. Then just also let us know, and I think I've already reported question 9, but we'll also try and report it up the chain to the IBM folks working on the content. All right, big ideas. You should know your way around the forums, or not the forums. You should know your way around the classroom, I guess the campus. You should know how to run yourself through media sets, including the videos, the readings, and the live coding activities. You should also know how to interact with the forums. So both the forums for the weekly discussion prompts, as well as the lounge and general Q&A, the technical Q&A, parking lots as well. You should understand how to run code in the IBM cloud. You should also understand the backup option of running code in Google Colab if something is not working. And then, of course, for week 1 specifically, you should have a better understanding of what it means to be a data scientist, the type of questions that data scientists solve, the type of products and data products that data scientists create, and the whole data science methodology as a mindset as you start approaching data science problems in the real world. Going into week 2, things to keep in mind. You do not have to do every single media set in week 2. There's a lot of them. If you have 0 Python experience, then yeah, you should probably do all of them. If you have some Python experience, you can probably whiz through all the way to about unit 4 here. That's where we actually start doing data science work with Python, doing our data collection from APIs, web scraping, all that good stuff. So breeze through media sets, units 1, 2, and 3 if you have some familiarity. Otherwise, start at the top and work your way through. Week 3 is going to be less work. So again, it's kind of like weird how some of the time allocation is. You should be spending maybe 10 to 20 hours a week on the stuff, including the live session. So I would say if you're honestly spending more than 10 to 15 hours a week, then let me know and I can help you prioritize. But yeah, I think I got an hour and a half. So this has been fun. Thanks for joining. Thanks for watching wherever you are in the world. And I will see you all next week. Great. Great job, Hinton. I'm glad you've already completed the quiz and worked your way through the notebooks. Yeah, let us know how you do with the week 2. Like I said, if you start at the top and just work your way down, it's a lot of content. So definitely pick and choose your priorities on the media sets. And definitely, I recommend Unit 4 and Unit 5 spending your most time on. And in our live session, those are going to be the notebooks that I'm going to review. I may hit 1 or 2 like Intro to Python notebooks, but I'm mostly worried about can you collect data from different data sources such as APIs, web scrapes, and CSVs? Can you load those data sets into pandas data frames? And can you start manipulating those data using kind of code and pandas and techniques like that? Great. Glad if we got everything aligned. I will see everybody next week. I'll upload this video tonight and we'll be around in the forums if you need us. Thanks, everybody.